Welcome to FUNNYMATH page. In today's lesson, I will discuss with you the angle properties of power lines. Power lines can never meet. Even when you extend the lines, they are not going to meet. There's always going to be a constant distance between the lines. So that is why you should know about power lines. They are not going to meet even when you extend the lines. So how do we get the angle properties of power lines? As we have these lines here, line AB and line CD, they are parallel. They are not going to meet. We mostly put arrowheads on them to denote that they are parallel. So if I use one arrowhead for this, I can use two for this one. So it's going to be the same number of arrowheads. So if I use two arrowheads for this one, I have to use two for this one too. So now I've decided to use one. So the question is, how do we get the angle properties of, power lines? As you can see, this line AB or that of CD, the only angle property that we can get from this is straight line angles property. So we take this line, for instance, you know that we have an angle of, 180 degrees, a measure of 180 degrees angle on this. That is for all straight lines. So apart from this, how do we get the other angle properties? So how do we get it? We can get those angle properties when we draw a line to cut across these two power lines or these two lines. So for example, if I get something like this, this line has cut across these two lines and we are getting so many angles here. We are getting so many angles. This particular line is called a transversal. So you can call it a transversal. So a transversal is a line that cuts across power lines. And when that happens, we are getting so many angles. And that is when we get the angle properties. So let me see the angles. This is angle A. We have B. You can give them, any letters. I'm just trying to give them these letters. So, the angles here, you see some of the angles are related, and that is how we get the angle properties. So you can see that the angle A and the angle E, they occupy the same positions, even though they are on different lines. This angle and that of this, they occupy the same positions. So they are equal. So we say they are corresponding angles. Apart from these two angles, we can also see that the angle B and F, they also occupy the same position. So let's see that one. Angle B and that of angle F. So you can also say that B is equal to F. They are corresponding. Apart from that, we can see angle C and that of G. You can mention that. So C is equal to G. And the last one, that's going to be D is equal to. So these angles that we find them here, they are corresponding angles. They are corresponding angles. And they are equal. So let's see some other properties of power lines here. Let's see that, A plus B, they're equal to 180 degrees in the sense that they are straight line angles. You know that straight line angles, they sum up to 180 degrees. That's not all. We have, C plus D. C plus D, they are also equal to 180 degrees. They are straight line angles. You can think of many. There are many here. B plus C equal to 180 degrees. You can also think of A plus D equal to 180 degrees. There are many. You can think of, when it comes to this side, we have E plus F equal to 180 degrees. H plus J equal to 180 degrees. F plus J equal to 180 degrees. E plus h equal to 180 degrees. So all these are, straight line angles. So let's see our next property of, power lines. We're going to talk about the next one, that is going to be alternate angles. Alternate angles form a Z shape. Like these two shapes, it can be of this form or of this form. So the Z shape can be this, it can also be that. And how do we get the alternate angles? The angles intercepted here, this angle and that of that, these are the alternate angles. So the angle here is actually the same as this angle. So they are the same, right? When it comes to this one, the angle here is also the same as this angle. So if here is B, and then here too is going to be B. So these are alternate angles. So like corresponding angles, alternate angles are also, equal. Let's come to the diagram here to see if we can get some alternate angles. So we're going to use this shape to identify that. So when you come here, we can see that we can form a Z shape here. Let me just trace with this one. So this, we have formed a Z shape, and this angle here and that of this, they alternate. So I can say that, angle D is equal to angle F. Oh yeah. I can also check this one. Let's see this one. Let me use a different ink for this one. This angle, let me just try and trace it. Well, yeah. So it has formed this particular shape. This particular shape. So you can say that this angle here is the same as this one. They form a Z shape. And so they are equal. They are alternate. So they are equal. So let's say that one. So we can say that angle C is equal to angle E. So these are the alternate angles. Okay, let's see the next property of, power lines. We have vertically opposite angles. Vertically opposite angles, they form a shape of, a scissors. So that's a scissors, right? They form a shape like this. And you see we have some intercepted angles here. So the vertically opposite angles are the angles that we form here, or we can see here, this and that, they are vertically opposite. And because of that, they are equal. So this angle here is the same as the angle is intercepted here. The same thing applies to this. The angle here is the same as this angle. So we say they are vertically opposite. So an easy way to, notify vertically opposite angles is to use the scissors shape. So let's come here. Let's come to the diagram. You can see that we have, something like a scissors shape here. This is, our scissors, and since we have that shape, we can think of some of the angles being vertically opposite. So let's start with A and C. The angle A is equal to the angle C, and they are vertically opposite. These two angles. We can also think of B and D. So we can say B is equal to D. When you come to the other end, we can also see that this also forms vertically opposite angles. It forms scissors, so we can get vertically opposite angles here. So we can say that E is equal to G and F is equal to H. So these angles are vertically opposite angles and they are equal. So they are vertically opposite angles. Vertically opposite angles. Okay, our next property of power lines. So I'm going to talk about consecutive interior angles, or we can also call it co-interior angles. So they are all the same. So let's see the consecutive interior angles, or the co-interior angles for short. So this angle, you see these angles here, this and that, they are all interior angles. And the one that you see outside, they are exterior angles. So when you take this C, this angle F is next to this angle C. Or you can also say that this angle C is next to angle F in terms of the interior angles. So we say they are consecutive interior angles. And what's the connection between these two angles? The connection is that when you add the two angles, you're supposed to get 180 degrees. So I can say that C plus F should give me 180 degrees. Or I can also say that they are supplementary, because supplementary angles are, they sum up to 180 degrees. So C and F are supplementary. They sum up to 180 degrees. Not only that one, you can also think of this angle D and angle E. They are also co-interior angles or consecutive interior angles, because D is next to E, or E is next to D. And since they are consecutive interior angles or co-interior angles, their sum must be equal to 180 degrees. So they are also supplementary. So these angles are co-interior angles. Our last angle property for, parallel lines, and I'm going to talk about angles at a point. And let's see how we can also figure out angles at a point. So angles at a point, they sum up to 360 degrees, because they form, something like a circle. The sum of the angles of a circle is 360 degrees. So that is why angles at a point, they sum up to 360 degrees. And let's see these angles. So when you come to this diagram, we have a certain point here. Talking about this point. Yeah. So these angles here, A, D, C, and that of B, they form angles at a point. It is forming something like a circle. And because of that, they form angles at a point. And their sum is equal to 360 degrees. So we have A plus B plus C plus D, and it should give me 360 degrees. So that is what you should know. Let's take the next one. When you come to this side, the angles here, angle E, angle H, angle G, and angle F, they are also forming angles at a point. And their sum is also equal to 360 degrees. So I'm going to get E plus F plus G plus H, and I'm supposed to get 360 degrees. So these angles are angles at a point. Angles at a point. That means they meet at a point. That'll be all for this video. Thanks for watching.